Wasn't there a podcast that was like in between two ferns? And then
Yeah.
did I just age myself
No, yeah,
a little bit? That's okay. Hi, everyone. Thank you so much for joining us today. I'm Diana Gehlhaus, Director for Economy at SCSP. I could not be more excited to have two amazing speakers who are going to share different perspectives coming from government and industry, and also former government, about AI plus careers when it comes to robotics and advanced manufacturing. So here to my immediate left, we have Michael Britt-Crane, who is, and I want to get your title right, Education and Workforce Development Strategist at NIST, and you had previously been at DoD's ManTech office working on advanced manufacturing strategy. And I have Joseph Larson, who is the Chief of Staff and Senior Vice President at Anduril Industries. So welcome to you both. Thank you again for joining us. And just for your all awareness, welcome to the SCSP family. We're a non-tech, non-partisan, tech-first special project that is really focused on this question of national competitiveness in a era of rapid global change and thinking about how AI and other emerging technologies are going to change the course of our economy, our society, and national security, and making sure we are putting forward policies that ensure that the U.S. remains an innovation power. So a little bit about SCSP. AI plus careers is getting at one of those dimensions, which is that workforce piece that's so inextricably tied to the economy. And we want to make sure that our workforce is set for success. And we're thinking about how AI is intersecting with the future of work. So let's just go ahead and get started, because I'm not going to read long bios. I would much rather ask you both about your AI plus careers journey. So let's start with you, Michael. And if you could share with us about your AI plus careers path to how you got where you are, what you're working on now, and what excites you about the future.
Sure. It's a pleasure to be here. Thank you for having us. I'm excited about this conversation. Yeah, so I'm Michael Britt-Crane. I am the Education Workforce Development Strategist at NIST. So I started studying mechatronics, and I worked on a DARPA Urban Challenge car autonomy in 2006. And from there, I did 9 years of R&D and got into a lot of STEM work for the Navy, and worked on some AUVs, started a marine robotics program, a couple of them. From there, I went, had an opportunity to come work at the Pentagon, and started what became the Manufacturing Education Workforce Development Program in the ManTech, Manufacturing Technology Office, and the Office of the Secretary of Defense for Research and Engineering. So I was there for 6 years. We did a lot of great things. We ran an SBIR program, started some digital learning products. It was a lot of coordinating and convening, corralling our Manufacturing USA institutes, helping them to work together on the workforce portion of their mission, where they have a lot of mission space in common with one another. And we also started the DEIA program there. So now, yeah, I'm at NIST, where I continue to work with the Manufacturing USA Institutes. There are 17 of them across 3 federal agencies, and we've got 2 new ones in competition. One which will be focused on applications of AI in manufacturing. So pretty broad topic, a lot of great work to do there. Building up the ecosystem around that, advancing the technology, and building the workforce. And then the other is a CHIPS Institute, digital twins for semiconductor manufacturing. So that's the other big thing, and the draw at NIST is the CHIPS and Science Act. It's a $50 billion investment in semiconductor manufacturing in the US. So there's a lot of creating of new things there, a lot of big workforce components. And so I'm working with that CHIPS for America office and all the entities in that enterprise, bridging in with institute activity. And I think that's enough to get started.
We'll definitely circle back to that. So much going on in the advanced manufacturing ecosystem when it comes to workforce development. Joe.
Yeah, I'll talk a little bit about my path here. Hopefully, the story will be about for those that are maybe in their early career and are worried about having like a particular focus or plan. I've never had one, and I think my story sort of evinces that like I've just kind of done what interested me, and it's kind of worked out and led me to the AI space. So the background was basically to go in the way back days. I'm not an engineer or a computer scientist. I graduated college in 2001 and joined the Marine Corps. So I come at this really from the mission side. And obviously graduating in 2001, it was a very interesting time to come into the Marine Corps. Had a very interesting first 4 years of active duty and participated in a bunch of combat operations overseas in the early 2000s. And then I decided I didn't want to be a Marine anymore. I got out and I went to law school. So that was pivot one. Did that for a couple of years. And by the way, being a lawyer, it was very boring. Around my AI story really starts around 2011 when I left work at a law firm and I joined Palantir Industries, which is a company in the data analytics and artificial intelligence space. At the time, they were maybe 150, 200 people, very small enterprise, and in Palo Alto, California. So that's how I kind of got involved initially in AI. Was not thinking about the technology for the technology perspective, but I was thinking about from Palantir, the mission side, which is how to bring a set of technologies to advance some of the core missions we were trying to accomplish for the Marine Corps and for the Defense Department. So I was there for about 5 years, and then I left there and joined the government, actually mobilized on active duty, rejoined the Marine Corps. This is my whole point on bouncing around a little bit, and went to the Office of the Secretary of Defense. And what happened in 2016 is there were a very small team of Marines that were there, and we started an initiative in the computer vision space called Project Maven. And at the time, it was just a couple of us. We never anticipated Maven would become kind of this phenomenon. Maybe those in the room are familiar with it and the story. Most people associate it with Google and what happened there. Happy to kind of go into that. But, really it was about, in that case, it was about bringing explicitly artificial intelligence, particularly advanced computer vision technologies to the defense intelligence enterprise for things like imagery and video exploitation. So within my 3 years there on active duty, learned a lot about the other side of the fence. So I was in industry, I was on government, learned a lot about, what it takes to build the technologies, build your workforce, what kind of skills you need. And then I left there in 2019, circled around, and then ended up at Anduril. So at Anduril, I'm the chief of staff today. And so as part relevant to this conversation, I oversee a lot of our workforce development activities, our recruiting activities, and I'm happy to kind of go into the way we think about those things in the AI space.
Awesome. Yes, we would love to unpack that a little bit more. And Project Maven has definitely carried forward and then some in the national security community, a huge contribution, especially when we're thinking about AI capabilities at the tactical edge. So, Michael, we hear so much about the CHIPS Act. We hear so much about semiconductors and reshoring semiconductor manufacturing. And one of the biggest battles or hurdles is the workforce piece, and that we just don't have the right talent in the United States for advanced manufacturing and specifically semiconductors. Can you talk a little bit about why this is important and why we should care about the advanced manufacturing workforce?
Sure. So manufacturing is pretty important to our economy and national security. That's kind of our starting point. Manufacturing punches well above its weight in economic impact. There's opportunity for a lot of great jobs there. And it's a tough problem because the industry was eroded over the course of decades, and we're trying to build it back up, especially when it comes to semiconductors. So semiconductors specifically are very important politically and strategically, it's one of the most advanced manufacturing technologies there is. And it's a very fast-moving technical space. So there's continuous opportunity to, compete there whenever the technology is advancing. You've got a chance to, retake ground in the very competitive global market. And I mean, to answer your question very bluntly, without a workforce, we can't have an industry, right? With chips, we're investing $39 billion in incentives with a lot of industry matching funds and commitments to build semiconductor fabs. And we need the workforce to do that construction and to validate and stand up and operate those fabs. So there's a lot of value there just to our economy locally and nationally, and a lot of great, careers. So it's pretty straightforward, right? We can't have this industry without a workforce, and it's a very competitive market, with most of the world's, especially leading edge nodes production in Asia, where there's, very tough work ethic culture, 996. I don't know if you've heard of that. Yeah, 9 a.m. to 9 p.m., 6 days a week. That's what we're competing with, right? So see it as a, the U.S. Congress sees it as a strategically important area and invested accordingly in that. I mentioned the 39 billion in incentives, the area where I'm working, with. Well, thank you. Yeah. Apologies, I'm combating jet lag and a little bit of a cold here. So I have to bear with me on the voice. So it's the other side is the research and development side, and that's where we're doing the work that I'm involved in. So it's a $11 billion total investment in the Chips for America office. I'm in the Office of Advanced Manufacturing. We're working very closely together between the two. And the thing that frankly was very refreshing to me coming to NIST, while this was already in process of standing up this enormous new operation in the Department of Commerce, was that from the secretary on down, workforce was a consideration from the start in standing up the chips operation. So it runs throughout. Every program has a significant workforce component, and there's a thought through architecture for how the pieces fit together and work together. On the R&D side and really workforce across all of chips, the Workforce Center of Excellence is the central node that's leading and driving this. And that's an activity operated by public-private partnership. Bear with me, there's a lot of acronyms and kind of complexity here, but with the Manufacturing USA Institutes and a number of other projects, really see the best state of practice for government programs, at least in the technology space, is to execute a lot of the work through these public-private partnerships, where the government is an anchor customer for this nonprofit that's operating, but they are free from a lot of the constraints we have as government entities. So the National Semiconductor Technology Center is a central player in the CHIPS research and development activity, and they operate the Workforce Center of Excellence. And the thing that's so exciting to me about CHIPS is the scale. So the Manufacturing USA Institutes have been around for over a decade. I've been working with them for 7 years on education workforce development. But the scale of investment with CHIPS is an order of magnitude higher. So there will be hundreds of millions of dollars through this public-private partnership for the Workforce Center of Excellence. In addition, there are investments across all these different parts of CHIPS, and employer commitments for the incentives programs, including so a lot of this is to be announced. So I have to be kind of vague on a lot of details here. These announcements will be coming out over the coming months. I think most of them will be done by the end of the calendar year. So $39 billion in incentives, the largest investments in developing new fabs are also going to have number one, big workforce commitments from the employers who are getting these federal dollars. Number two, a regional intermediary to develop the workforce systems within that regional ecosystem, the regional economy, work with the education, training, and employers, as well as economic development, wraparound services, local government, to understand what is the hand that they have to play, what are all the assets in that ecosystem, and what are the workforce needs specifically for the semiconductor industry, but of all the employers relevant to that industry in the region. So there'll be a network of those regional coordinators working on the workforce problem tailored to that region, and then coordinating nationally through the workforce center. So there's a lot coming through this program, and just a much larger scale of investment. We've been at this with the institutes and a number of other programs. I'll mention the tech hubs out of the Economic Development Agency and the Advanced Technological Education Program out of National Science Foundation. But there's like a dozen or more programs across federal agencies investing in workforce solutions, and specifically at the institutes, emerging technologies. How do you proactively build the education and training needs for the workforce for a new industry, for a technology that is emerging, that we don't know the final shape of it yet? We've figured a lot of that out. We've got a lot of solutions, many of them at small pilot scale, some of which have started to scale up, and we're ready for this next phase of investment at the hundreds of billions of dollar level to really start cooking with gas on workforce development for advanced manufacturing.
This is incredible. And at a scale I had not seen in many previous federally funded initiatives. And so I'm really curious. I want to clarify, when we say education and workforce development partnerships, training programs, are we talking about K-12? Are we talking about the college experience, graduate experience, all of the above? And also, to clarify, are we talking about I think people, when they hear about semiconductors or in AI, it's very high skill, very requires a lot of technical training to be able to do these jobs. A lot of times a 4-year degree in a STEM field. Are we talking about there's a broadening science and engineering or science or technical workforce that maybe doesn't require a college degree? So in terms of the jobs that you're talking about here, and in terms of the education level you're talking about here, can you clarify that?
Yeah, good question. I think it's important to recognize that it is all of the above, but there's a natural progression as technologies mature and industries start to scale up. At the beginning, the technology is invented by PhDs and start to implement it, and it's used by scientists and engineers. And so that's where the workforce needs are, right? As you're maturing the technology. But in order to scale up an additive manufacturing industry with, trillions of or billions of dollars of production, you can't do that with scientists, engineers. So you need to bring that down to the operator level for the skilled technical workforce. So it is across the board. These programs are across the board. There's really innovative things in the inspire and attract problem. We have the, reputation of manufacturing to contend with, and the fact that it has gone overseas, and there's been a lot of hardship with job loss in plants closing and offshoring. So inspiring and attracting, we need to feed that pipeline. So there's hundreds of programs that the institutes have launched across all of these areas, but the one that I focus in on as the area of greatest need and greatest opportunity is that skilled technical workforce, because that is where we can have the greatest impact. That is what is needed to go from, a low technology readiness level, products, parts in a lab, to products on the shelf, and get to the scale where it moves the needle for the American economy and for jobs. That's the skilled technical workforce. That's what we need to make advanced manufacturing economically viable for prosperous regional economies and companies and individuals here in the U.S. Is that skilled technical workforce. So it is across the board, but I'll throw a couple stats out here. So there's over 500,000 job listings in the manufacturing sector per year. Half of those are going unfilled due to a shortage of talent. So it's 250,000 jobs per year that are going unfilled because we don't have the adequate workforce systems, education. We don't have the talent to fill all those jobs. And a portion of those are in semiconductors. So that if we sort of come back to the SPSC mission, and the vision of U.S. leading in global competitiveness, again, I'm looking at manufacturing primarily. The only way we do that is with a robust, skilled technical workforce, using AI, empowering them in their jobs, and driving productivity and high value manufacturing here in the U.S.
And we'll circle back to some of the policy implications from this massive investment and the role of the federal government in some of these education and development initiatives. I want to come back to you, Joe, from the industry perspective, thinking about some of the comments here about the supply side and you see on the demand side. But also you're at a different part of the ecosystem where you're really on the leading edge of developing some of these capabilities, that cyber physical convergence. Can you talk a little bit about what Anduril is doing at that leading edge in terms of developing capabilities that involve that cyber physical convergence and what you're seeing in terms of workforce trends?
Yeah, absolutely. I wish I had a $39 billion investment to announce we don't have that. Although, certainly in industry, we would applaud the work of NIST and the federal government in advancing these things, because it's going to help build a workforce that we're going to leverage across the entirety of our production, our engineering, and our supply chains to build and deploy reliable and secure products for the warfighter. So, it's certainly really great work that the federal government is doing with CHIPS Act, with NIST and with others to advance these workforce development issues. I guess my perspective on this is, for us, when we look at our workforce retention, workforce recruiting, workforce development, there's really only three reasons why, if pay and compensation, quality of life, if you take those aside, why like a leading really good engineer would want to work at a company like ours. The first is, the mission impact, right? The idea that, by working at a place like Anduril, you'll be able to advance national security mission that matters. It's something that's good for national security. It's good for America. It's good for Western development. That's number one. Number two is, the problems that we face are really unique, right? And they're not exactly the kinds of challenges you would get at any tech company. I'm talking about the integration of autonomy into complex systems, access to data from really unique and exquisite sensors, bleeding edge AI models, the ability to take a lot of engineering investment and sort of work that into products and then deploy those products. And, it's very different than the type of engineering, computer science experience you'd get at a pure R&D facility where maybe you're working on something that's interesting, but you're never going to see it deploy into production, or like you'd get at a major tech firm where maybe, you've got great infrastructure, but you're working for years to deploy a line or two of code into prod, right? For us, it's like the ability to actually see your work deploy into systems really matters to our workforce. And then, the third reason is a belief that your personal and professional development will be enhanced through interaction with the enterprise. And this is the one we focus on the most. This is mostly taken from an engineering aspect, but it's the idea that it's beneficial to both the company from a recruiting and retention perspective, and also to improve the deployment of our products, to meet customer expectations, to convince the customer, which is the national security enterprise, that we're deploying the best engineers, that we provide a workforce that has opportunities to up level, to upskill, to get training, to get adjacent training, and to spend time. And that takes lots of different flavors, right? It's third-party certifications, it's degree programs, it's time off, it's on the job training. And so, thinking through a productive cycle of like how those investments work helps us upskill our workforce and provide opportunities. And so people want to come because they believe when they join the company will enhance their ability to, upscale their engineering and their professional development, whether they stay, most tech companies, as we're not probably building a workforce that's going to stay for 30 or 40 years, right? They're going to rotate through and go to other jobs, and that's fine. We don't mind that at all, because we're also benefiting on the back end of that, right? So I think those are the ways we're thinking about some of these issues of, how to invest in workforce development, workforce improvement, and providing training opportunities for our cadre of engineers.
Fantastic. Oh, go ahead.
Just going to say, as a mechatronics engineer, I see the appeal. I may be biased, pretty mission-driven guy over here.
Oh, well, that's important. And that's an important part of the national security community's recruitment marketing campaign, if you will, is the mission. But what you both are touching on is something that we touched on a little bit earlier today, and also something you touched on earlier today when, Joe, you mentioned earlier today about how Anduril really is focused not on dual use technologies, but on advancing the national security mission. And when you're both talking about careers, you're talking about skills ultimately. And there's a huge push right now about skills-based hiring, and competency-based education has been around for a while. It just hasn't really ever taken off or found its way. I'm wondering if, as you're talking about all these education and training initiatives, as you're talking about upskilling your workforce and the convergence of different skill sets across disciplines to be a good, an engineer at a place like Anduril, are you seeing ways around just, here's the 4-year degree and that's it? What are you looking, what kinds of education and training models are you thinking about, and what kinds of skills are you looking for? And are you just looking for a straight degree? So whoever wants to start first.
Yeah, I mean, I'll jump in. I feel like, unlike my colleague who actually has the challenge of building an entire national enterprise to, I'm just worried about sort of like the limited problem of like the workforce development of our, our core of engineers that are building our products. So, our incentives are perhaps a little bit different, and much smaller in scope than what you're working on. I will say with the degree, as I mentioned, I'm not an engineer by training. I feel like I've had to adopt and learn a lot of it as I go. Well, what we're finding is, first of all, in this field, the degrees matter less than you would expect, right? Like, I don't know that we even do any real degree screening as part of our recruiting process, and certainly not as part of our promotion and employment review process, largely because, we're getting a large number of people coming in that are self-taught, that are self-learned. Our founder, Palmer Luckey, is a good example of this, right? No advanced degree in engineering. He built a company when he was 19 years old. And that's a lot of our workforce. So what you're really looking for are a set of intellectual curiosities. You're looking for people that are aggressively curious, that are comfortable shifting and moving in different domains, right? Like I don't know that Anduril is the right spot. If you're interested in somebody that, if you're somebody that perhaps wants to get into one area of like a specific technology and study it in depth, get that PhD and learn it. There's lots of great R&D enterprises and phenomenal institutions. I would say ours focuses a little bit more on the generalist model, which are, really anybody that's there has to understand the technology, how it works, but then also how it integrates in products, how those products are used, the implications of the technology and its performance for that end use, right? Like the integration of software and physical components of an end system. When you're talking about AI and we're talking about autonomy, there's a lot that goes into understanding the reliability and trust of these systems when they're deployed with our customer, which is the defense and national security customer, which has a unique set of considerations that are driven both by regulatory, sort of domains, but also just on the, the fundamental problem of like, is the technology reliable and does it work for the warfighting ends in which it's applied? So, I would say that probably, our opportunities tend to invest a little bit less in taking an individual and walking them through something highly granular and becoming an expert, to the nth degree, PhD level in a specific set of technologies. And we're focused a little bit more on the generalists. You know what I mean? The opportunity for somebody maybe who's got deep engineering expertise to do a rotation where they're working with products on the edge, spending time with the user, spending time with the warfighter to see the technologies in use, vice versa. Taking somebody who maybe has spent their career as a Marine and done a lot of the operational implementation, taking them out of that and taking them back into the research lab and saying, oh, you're building a computer vision model. We're going to use that for operations, but now I can actually see the data that's been labeled, the development environment for that artificial intelligence, the test environment. So I understand those scores and what they mean. I understand the limits of the model, the limits of the AI. And I think I think that's the advantage of being an end-to-end sort of product company is you can people will respond to the idea of being able to work across the technical integration and deployment aspects of the company to sort of build an end-to-end understanding of how the technology comes together to sort of work to solve a mission. So I'm not saying that meets everybody's requirements. That tends to be our approach, and I would say there's other approaches that would work. Particularly it's heavy on the R&D side, but we find that the people who are more interested in that holistic view are inclined to the company, and it's our view that we need to give them the opportunities to explore that.
Yeah, and I'd love to hear your thoughts.
Well, I'll just say, sounds like a really great model. It could be a great place to work and get exposure to a lot of different things. See your products deployed again. The mechatronics engineer in me sees the appeal.
I would like to say for the record, I am not taking responsibility if NIST loses this person to Anduril.
We don't have $39 billion.
I don't think so. So yeah, I mean, it's admirable. Like really always love to see the story of a company doing it right. And I'm curious sort of how much of your workforce is now and maybe down in the future is in the engineering, 4-year degrees versus skilled technical workforce, and how that shifts and whether, it seems like that general principle, that approach could apply to both sides of that workforce. But that's, yeah. So the issue is though that not every company is Anduril, right? Again, manufacturing is the industry I know best, so I'll speak to that where, value and employment wise, about half of manufacturing is small and mid-sized manufacturers, but it's like 98% of manufacturing are companies with, I think it's 50 people or less. It's a lot of very small enterprises that don't have aren't in the same type of position that Anduril is to be able to have such a healthy workforce policy and cultivate the workforce. It sounds like you're doing skills-based hiring in one way or another, and very enthusiastic about the idea of skills-based hiring and competency-based education. The problem is it's just much harder to implement than, it's easy. We measure what's easy, right? Numbers are easy, GPAs, and the universal credential is the 4-year degree that is well understood across industry, and in many cases, hiring managers don't necessarily have all the information or the incentive structure to be able to take the risk to make that leap from the more traditional hiring that has more credential requirements, and specifically the big one is that 4-year degree, to skills-based hiring. But that really is where we need to be. We're not going to get there with traditional hiring approaches, and I do think over the long term, this workforce shortage in industrial sectors like manufacturing is not going away. So the companies are going to have to move eventually towards that skills-based hiring approach. But the problem is that it's risky. And there are a lot of things it can be done. Like there are a lot of things that can be done. There's a lot of inertia. There's a lot of momentum behind the traditional approaches. The old saying, "You never got fired for buying IBM." It applies here, right? You never got fired for hiring somebody with a 4-year degree. What's the incentive for a hiring manager to hire somebody who doesn't have that traditional credential for this, this position that they're trying to fill? So that's the problem. Now, on the solution side, there are a lot of exciting things. I mean, I'm really encouraged by the reskilling and upskilling that you guys are doing. That's really what we need. And so, tech guy, I apply the technology lens first, and you look at the pace of change. We were talking earlier about the evolution of other industries that took decades and decades and decades, but we see the proliferation, advancement, or well, really it's the advancement and then subsequent proliferation of AI based tools and applications. That's going to happen very fast. And it's harder to see the future in the AI space than in other technologies, but I think it's pretty clear that the pace of change is accelerating. And 4 years of study for a 40-year career absolutely does not work anymore more in today's world. But increasingly, what we need is a continuous education, a continuous learning system, right? So that you're upskilling constantly, having the types of opportunities that the technical workforce at Anduril has. But again, not every company is Anduril. We need to have the infrastructure in our community colleges to be able to support that. But we really need to move beyond these traditional models and develop. And really, the crux of the issue is credentialing. We were talking about this earlier after the panel. The big issue in credentialing is that it's a social problem, right? It's again, take another metaphor from tech. There are too many standards, so we need a new standard to rule them all, and then you have one more standard. So you've got the same Wild West situation happening in credentialing, where there are thousands of them, and most of them are meaningless. So what you have is a really tough social problem, and there are ways to solve that. Attaching to big brands. If big companies like Anduril, Microsoft, big names embrace it, then you can bootstrap the brand of that credential and give it currency in the marketplace. And we've seen that but it takes time. So what's even more exciting to me are some models that we're starting to see potential in to sidestep credentialing for skills validation. And again, it's see how this plays out, but I do think there's a tech platform play here that could potentially validate individual credentials, individual skills, rather than these bundles of skills we call credentials. And probably not a good idea to get into all the details of how that could work. But there are nonprofits and companies working on these types of models, and it's pretty new. That's pretty new. But there's a lot of things that do work that aren't that new. I mean, we've got you can hire people on a temporary basis, see if it works out, and there's hiring agreements, but it's a lot of shoe leather work, right? Relationship based network building and that sort of thing. And that takes a lot of time and effort to accomplish. And frankly, I think we need to move faster than that. So, it's excited to see some of these things that we've been tinkering with for over a decade at the institutes and other places have the opportunity over the next few years through chips and science investment to turn the knob and really scale that up and see how it works at a larger scale.
Yeah, I would jump in. When we talk about like where we're at, everything you say resonates because, when I look back to the company we were founded in 2017, 2018, 2019, 2020, you're talking sub 500 employees. At that time, the number one source of hiring was internal referrals, right? Like it was the network. And for every employee that came in, essentially you had the opportunity, from the CEO on down to get to know them. And, in the course of their development, build a sort of custom and bespoke path. It was easy to move people between divisions. Now we're, by the end of this year, we'll be over 4,000. Probably in the next couple of years, we'll be up to 10,000. And when you do that now, I noticed that these challenges of, the credentialing candidly becomes much more important, right? Like process becomes more important. We have to have the means to make things fair there isn't the opportunity to go out and internal referrals become much more unique. Right. And so like it does, I would not represent like a panacea, like it's, we're facing what I think every company in its growth period faces, which is like thinking through the challenges of recruiting and development as a bureaucracy or as like a large company versus at a startup. And that maturity it's a hard thing to do and to do well and to keep the employees satisfied. So everything you say like resonates. And so I just want to provide the counterpoint to, sort of our philosophy is like how we keep that going as the company scales.
And what's interesting is how AI starts to infuse in a bunch of these conversations, right? Like AI is an educational tool and an assessment tool. AI as aid in making what we call making the bureaucracy go faster in terms of HR and in recruitment, which is a double-edged sword. That there's a lot of issues still, getting worked out. Lots of great conversation going on about that. And also what I want to turn a little bit to is AI actually as part of your job and how different professions across the communities that you represent are engaging in AI, right? Whether they're helping develop systems that involve an AI component to it, whether they're integrating AI into the manufacturing process. So I'm curious, as we start to think about how AI is infusing a lot of these conversations. It's almost compounding some of these conversations, and at least accelerating them. To your point, share a little bit with us about how AI is impacting the workplace.
Yeah, I mean, I'll jump in. I would argue, maybe I shouldn't say this out loud, but I'll say it, which is if you take the definition of AI, which I believe is the sort of like the current definition, which is really tied to machine learning and particularly recently generative AI. That seems to be we have more of that in our business and enterprise applications, to drive the company than we do in the products, right? Like a lot of that is driven by the fact that like generative AI is not a solution that's probably appropriate for a lot of military grade products that we sell, to the national security establishment. But it's also on the flip side, it's due to the fact that these technologies have tremendous implication for like managing a distributed and complex workforce, right? So, like a lot of companies, we built and deploy our own internal large language models. We've used RAG and other techniques to, infuse the model with knowledge and training data based on our enterprise. We're experimenting with the means to be able to, use the model to drive business decision and business decision making. And then it applies across the range of like company functions, right? Everything from HR to legal to finance. Each of them touch AI and AI applications in what I would call interesting ways. It just depends. But at the end of the day, for us, we have to be able to effectively leverage these technologies as a value differentiator versus our competitors, or we're probably doing it wrong. And I think, I think like we're experimenting with everything from like really niche stuff, which is, how can we use, large language models for basic back-end tasks and like to automate certain processes, manage our travel claims or whatever, like kind of boring stuff, to really the big picture stuff, which is like, how do we have it inform large scale business strategic decisions and drive things that come out of the CEO's office. And, in the former, I would say some of them are moving in production. They're embedded in the products, that we buy from third parties increasingly. In the latter, they're more still experimental, but they're areas where we're going to invest.
So I think it's pretty clear that AI is at the very least going to be, or these, I think you defined it pretty well. It's like, what are we talking about when we say AI? An accelerant, right? The convergence. We talked a lot earlier today about convergence of AI and robotics and how that makes it so much more accessible and brings down the cost and opens up a lot of application space. So in the advanced manufacturing, space like that, that's a huge, we expect that to be a huge accelerant. And that's where we are focusing a lot of our new investment is in the use of AI tools, development of them, and application in the manufacturing space. But to your point at the beginning, Joe, there's moving from the low risk generative AI LLMs, making GIFs on your computer, to operationalizing it in an industrial or military context is quite a leap. So realizing that potential that we see is what I view as the big challenge to operationalize it and realize the benefits, and not just go from a toy that maybe helps you get your job done here and there, drive some efficiency, helps you with your travel receipts, the travel claims and stuff, to something that's really transformative. I worked in autonomy in undergrad and in my engineering days, and it's pretty obviously how transformative these, starting with ML, but getting into a lot of the cutting edge AI tech is really opening up, computer science 2.0, right? The things that were very, very, very hard are now getting trivially easy, and the capability of these autonomous systems is exploding. TBD how that sort of plays out. So trusted AI is the area where we've got a lot of focus at NIST. We have a whole institute dedicated to that. It's a big part of the investment again in AI technologies for industrial applications in manufacturing and semiconductors. And I know that's relevant to your mission too. So I'd be curious to hear about how, well, I don't know what you can talk about, but how the trusted AI and how developing that as a technology sort of fits in as a cutting edge, military technology company.
I mean, we don't trust it, right? I think, do any of you trust AI? I don't trust AI. I think there's a verify aspect, so, I don't know if your question is more about the products we build or more about like how we leverage it for internal sort of purposes. The latter really driven by customer constraints, the internal driven by our own sort of business equities, but, varies.
Fair enough.
So, and evolving, right? So there's a continuous monitoring piece about that and a framework piece. And a lot of people have different viewpoints when it comes to some of these trustworthy, confident ethics conversations. It's actually really fascinating. And I think more frameworks, more standards. I don't know what the answer is there, but good questions. I want to just to build on some of the threads that we've already started to put together. It became clear from the demos earlier today, from some of the discussion earlier today, that we're at a really interesting moment when it comes to what I'll just call physical AI right now. So it's not that we expect humanoid robots to be helping us complete daily tasks imminently, although that is on the horizon based on some of the conversations and demos that we've seen earlier today. And there's a lot of investment happening, not just in the US, but in China. I was really struck by the fact that they've got so many companies that are working on this. However, we are seeing deployment of robots in factories today. We are seeing some serious advancements in autonomous vehicles, potentially autonomous cars and trucks, right? There's been, finally, it seems that there's been some serious progress there. And we are seeing deployment of autonomous systems, back to some of what you were just discussing, in drones, in theater already. We heard about how Ukraine is addressing some of their warfighting, or has completely transformed some of their warfighting tactics. And we hear about autonomous submarines right. So we are starting to see signs that human robot or human AI enabled technologies are really starting to come together, or that we are seeing not just Gen AI and LLMs, but we're seeing other types of AI enabled systems come in. I'm curious if you're seeing any signs so far in terms of the skills that are in demand, or what you see in terms of the skills that people need to have to be successful, both in the advanced manufacturing space and in the sector you work in.
So I think it's a little early to say, what we're seeing in terms of that skills need. Obviously, there's a lot of tech development, and that's driving skills needs. There are still a lot of question marks about how the question I was trying to get to earlier, like how we will be able to get to a point where we can validate and trust AI in these industrial contexts. And as you said, we're starting to see that, but the validation models, and the crux of the issue, I think, is going to be trust, reputation, liability. Like, those things aren't going to go away. Yes, AI might be able to do things, improve efficiency, open up new markets, do a lot of new things, a lot about bringing costs down. But at the end of the day, there are all of these human factors in the way we operate our economies, our businesses, that some of them probably won't move very much, right? And that's what's so exciting about AI, is it's really hard to see around the corner. But I do think that you can see things that it's very good at, and things that it's absolutely terrible at. I'm thinking of LLMs and like modeling, something we can do in our heads, but LLMs can't do at all. That might change in a couple of years, but there are definitely, I think it's, we've seen throughout history, and it's expected to remain true for the foreseeable future, that human machine teaming is going to be much more powerful. There's a long story about the O-ring in the space shuttle, right? The larger and more complex your system gets, the more each individual component, the more value each individual component has. So the space shuttle, the space launch system, one of the biggest, most complex systems people have ever built, failed because one small little O-ring failed, right? So as we build larger automation systems to enhance human productivity, that's going to continue to drive up the value of the human in that loop. We will become the O-rings in the space shuttle system, and that puts more emphasis and demand on the human and their skills. It's a long road to hoe, right? To incrementally get there. This is going to move much faster in historical terms than other technologies that we've seen. But it's easy to sort of overestimate what's going to happen in the next year and underestimate what's going to happen in the next 5 years.
Yeah, the question was, what are the relevant skills for an end-to-end AI-enabled workforce, right? That we're seeing in terms of the trends. I was a couple weeks ago. I was at like a major venture capital funded, event where it was all AI companies in the room, and I had an observation on the difference from what I saw in 2024 versus what I saw in 2021, or even going back to like 2012. I would say it sort of was like a model that represented what we're seeing widespread, which kind of is like there's a microcosm in any AI project you do, which is initially the focus is on like the AI itself, the model. What is the model? What's your model performance? We saw this with computer vision and like ImageNet performance with like, can I get incrementally better precision and recall scores on like a standard set of training data versus my competitors? We see this with generative AI, where it's like your model metrics on like Hugging Face or whatever matter. And it tends to be that like actually that model layer of the AI stack, it's pretty well invested in. There's a lot of, players and there's a lot of good tech. But I would argue that where we're needing workforce competency is in other parts of the AI value chain. And what I observed at that venture capital conference, which was also aligned to my experience and the type of companies we need to work with, is that they are pushing, that model is like your patty in the hamburger. The bottom layer is like your whole infrastructure. And most of the companies that are getting investments these days for artificial intelligence seem to me to be AI infrastructure companies, companies that are building your data pipelines and your RAG pipelines. They're doing like your DevOps environments. They're, so like all those things really matter a lot. And those are areas where we're investing in and trying to upscale our workforce, is to just understand the range of data and how that data will flow into sort of a model architecture. Where I haven't seen the investment, and I think it's coming in the next 2 to 3 years, is then flipping from the bottom of the patty up to the top, is all the integration work. Like I still haven't actually heard anybody provide a crisp articulation of the major use cases of generative AI, particularly large language models that drive like business value. I mean, I hear ideas, it's going to be your assistant or whatever, or it's, but like, what are the use cases and like, how do they manifest? And there's a whole set of skills that I would advise if you're interested in building a career that are going to be particularly relevant here in terms of, the intersection of AI and mission. What are the objectives you're trying to accomplish? How does AI inform that? How does that whole, how does it above the model, how does the integration work? How does it integrate within a system? And then as a subset of that, all the sort of trust, reliability, model test and evaluation, model feedback loops, all of that is embedded in that, right? And I think like, and that actually probably ties back to infrastructure as well. So that probably runs the whole value chain of AI. But I would argue like, it's tempting to probably think that an AI career path has to be, I go to school, I study AI, I learn about how to build the model, right? And that's what I learn in my computer science program. So that's what I'm going to do. But probably most of the actual jobs and investment that occur are going to occur elsewhere in the AI value chain. And I wouldn't undersell, thinking about these components of like integration, testing, pipelines, infrastructure. They'll continue to be the primary area where we need to invest in workforce up-leveling as we proceed down this path.
There's just a lot of implementation that needs to be done, right? And AI creates like entirely new applications become possible, and that creates a whole industry and a whole set of jobs around that. So AI enabled jobs are a whole other layer to this, right? That additive, and there's a lot of tech that's enabled by AI creates a whole opportunity for something that works here in the US that previously was offshored. And a lot of those jobs, like AI is at the center of it, because that's the tech that the whole company is built around potentially. But they're going to be using their interface with the AI would be more in the business operations side of things that you described in Anduril.
Kind of like the Chris story around that is like, there's been a number of circumstances I could identify individually where there was an obsession with like AI performance up to a certain point, yeah, I'll just say human level performance. Take that as a generic characteristic. I know it's hard to define, but say human level performance on a defined basis for any individual function, right? And the idea is if we just get the AI there, then it will somehow self-manifest and proliferate and like solve our problems. I can think of several examples. If you hit me up after the conference, if you want specifics, where actually we achieved that, in the computer vision space and the language space, where we were able to say for like a mission function, the AI, given a set of input data, will perform above humans on a defined set of tasks. And then you know what? It just sits there. Nobody knows what to do with it at that point. There's a whole set of problems that come after that value point that I think are an area where if I were, at the beginning of my career and thinking where I want to have impact, that's probably where I would focus my time and energy.
That's fascinating, actually, and leads me to my last question. And that is, I think there's a lot of uncertainty out there about what the future holds. None of us are fortune tellers, unfortunately. And people who are just starting out or people who are mid-cycle in their career, I'm curious as to what advice you give when they see very evocative commercials, and like the one, there's a commercial that's out there right now. I don't know if that's got a robotic arm, and it's, there's you can either have a robotic process manufacture your stuff, or you could have humans do it. And isn't that so much better? And then at the end, the robotic arm gets crumpled into a sad ball, but it's trying to evoke fear about what the future holds and what these technologies are going to bring when it comes to livelihood and the economy and your well-being. And so in the face of, what some people see as excitement, some people see as anxiety or apprehension or uncertainty, what is your advice for people who are thinking about what this next frontier of jobs could look like? How can people become one of the 10,000 at Anduril? How can people make the most of opportunities that are coming from advanced manufacturing? And we'll start with you.
So I think about the applications. It's pretty easy, like at a superficial level, just kind of watching from the sidelines to see, a number of jobs that could be displaced or just replaced by automation in this new form of, mechanical minds, right? But what's a little bit harder to see, but you can see them. If you get a little bit closer, is the jobs that are going to be created, and sort of what we were, getting at in that little bit about the implementation jobs, the jobs that AI makes something new possible, and there's a whole lot of jobs around and careers around implementing that, building a company on it, figuring out how to operationalize it, make it efficient, bring it in a new direction. There's just so much opportunity space around that. So whatever area you have domain knowledge, you have education, training, or hobby experience, or whatever the case may be, wherever you can imagine, this technology is developing pretty fast. If you can imagine how it can sort of play out in that area, it's probably something that's going to be possible in the next few years. And if you can position yourself in a place to take advantage of that and build a career off of that, that seems like a good move to me.
Yeah, a story on this. When we started, I mentioned I led Project Maven briefly, and was part of the team that stood that up. When you go back to the founding of that particular initiative, you can read the founding document. It was called the Automation Task Force, and it was designed specifically to automate away the jobs of 6,000 people in the defense enterprise that sit and stare at video screens all day, right? And the idea was, hey, computer vision works. We can get it better than human level performance. The exploitation of this video is actually pretty rote. It's something like a computer can do. It's find this person, find this car, whatever. So we'll just automate away those jobs. And of course, here we are 8 years after Maven started, and I don't think there has been one real job that's been automated away. There have been transformations, right? Like there have been changes in the workflow as some of these technologies have taken hold. But the thing I've noticed is that in every instance where you've been able to integrate the AI to perform some sort of function, there's like 3 or more trailing, jobs or like functions or like requirements or challenges that come from that. So, I tend to be an optimist that like there's no real concern that I think we're a long way away from any concern that I know somebody on stage, I think, said this morning that like robotics are going to kill all the jobs and we should just get used to it. Maybe that's true in a lot of industries, at least in the ones I work on in the defense space. I don't think that that's true in anywhere the near or medium term where we should be really worried about it.
A closing advice, though, if somebody said to you, what should I study? What should I do? What career should I pursue?
I mean, no, I don't know. Do what interests you. You know what I mean? Pick the thing. I guess the idea is if you're an AI optimist, and I tend to be one that thinks that these technologies will evolve and change like a lot of the way we do business, particularly the national security establishment. There's almost no job you can select that doesn't touch this in some way. And so it's going to be hard to avoid. I recently finished this curriculum called the Army War College, which is like, it used to be 10 years ago, you go there and read your Thucydides and you read your Clausewitz, and then you debate on a whiteboard the future of maneuver warfare. You know what it was all about? The 2 years I was there was about AI. Every third class was about, can we use AI for better mission planning? Can we use it for more effective military operations? I don't know that there is a field that this doesn't touch. So you should be less worried about trying to get into it and recognize that whatever you're interested in, it's probably going to touch it in some capacity.
Great advice. We call it AI plus X. So thank you so much for sharing your insights. Please, everyone, feel free to join us. There is a reception that is in progress. So please feel free to stick around, network, continue the discussion. In the meantime, we'll see you next month on November 12th. We have Justin Reynolds from the State Department for another AI plus Careers event. And we have additional events coming in December and January and February and beyond. So thank you so much, everyone, for joining us. We'll see you soon at AI plus Careers. And please join me in thanking our fantastic panelists today.